Greetings, my name is Jonathan Day. I'm here with Machina Cognita Technologies. I'm going to be talking today about our capability, Smart Translation Engine. This engine is focused on providing an interface between human autonomous systems that allows for control and discussion between autonomous systems with Marines or sailors or soldiers through either voice or chat commands. Machina Cognita Technologies is a machine learning research and development company located in San Marcos, California, just north of San Diego. We've been around since about 2017 and are a service-disabled veteran-owned small business. We do a number of things, including research and development for the military, as well as development of sports training applications for baseball, softball, soccer, and hockey. And we also have commercial offerings in the field of esports. Currently, we have a number of SPRs in Phase 1 and Phase 2, and our corporate leadership has had quite a bit of experience transitioning these into Phase 3s. We're definitely looking forward to any potential partnerships in taking our current Phase 2s, including the SMART system, and working with transition partners and getting those into Phase 3 efforts. Today we're going to be talking about our SMART translation system. Its primary focus is on the integration of autonomous systems within existing military operations. Military leadership and military operations have a long history of how they communicate with each other, the type of language they use, the doctrine that they follow for various levels of communication, whether it's operational orders, sit reps, spot reps, call for fires. All of these have very distinguished and very well-known formats that they utilize, whereas autonomous systems really don't understand any of that. They would really talk in form of JSON or other machine understandable formats. And what we want to do is be able to translate between what a machine will understand and what a human understands using these doctrine-based formats. So we're looking at converting natural language either in the form of chat or messages or in radio communications that follow this doctrine-based communication into a format that a machine understands. So allow for humans to provide observations to the autonomous systems, provide commands to the autonomous systems, or any other number of communication patterns. In addition, we do the reverse, where we allow autonomous systems to provide information to human operators and for Marine sailors and soldiers in terms of either observations that they're seeing, recommendations for actions, or questions and answering. Really any type of communication that you would like, we can help facilitate that interaction between human and autonomous systems. As I was saying, the real operational use for the SMART translation engine is to enable military personnel command to inform autonomous systems through doctrine-based communication. These include a wide array of military doctrine comms and can be easily extended within a few minutes for any additional communication patterns that a transition partner might be interested in using. Currently, we support 5-paragraph op-ords, salute reports, 5- and 9-line close air supports, and a large range of others, including question answering, observations, and orders, both from and to autonomous systems and from and to human operators. So what we do is we convert those into JSON messages that the autonomous system can understand. We design and update those JSON messages for each of the different autonomous systems that we interface with. Currently, we're interfacing with over half a dozen different autonomous system operators, and we can add in additionals very quickly. This includes being able to communicate via TAC devices, radio communications, TAC chat, or other chat message chat servers, and as well as full documents that you might send via email or upload or any other way that you would send documents to humans. We can receive those in the exact same way. Basically, it provides military personnel with real-time feedback on potentially ambiguous content, implications and presuppositions, as well as areas for improvement in their communications. So it really alleviates the need to have very direct, very complete information being provided to autonomous systems, and the system will infer the missing information. It will disambiguate anything that's potentially ambiguous, and provide a complete list of information that the autonomous system needs to do whatever the human is looking for it to accomplish. So some of the system technologies that we're utilizing for our solution include natural language processing, natural language generation, and natural language inferencing using deep learning models. These allow for a wide array of understanding of natural language, whether it's coming in from the human and being translated and understood, or it's being pushed out in the form of natural language generation from a autonomous system trying to tell a human something, being able to translate it from JSON into natural language. Some of the skills that the system utilizes is presupposition and implication detection, sentence classification, question answering, speech to text and text to speech, so that you can go both ways with speech, dependency parsing, semantic role labeling, and entity recognition, co-reference resolution. This is a short list of all the capabilities that we have under the hood, but it is an extensive natural language processing capability. The current status of the Smart Translation System is that it is a complete end-to-end system that has full functionality. However, we are adding new capabilities and enhancing our current capabilities as we progress through the phase 2, and we'll continue to do so as we transition into programs of record. Currently, we have been able to test the system within live experiments, including Marine Corps force-on-force exercises. These operations included human operators as well as a number of autonomous systems, including recommendation engines, robotic systems, including autonomous robotic systems, and both at the squad as well as the platoon level of operations. Currently, we're at about a tier L3-4, and we'll hopefully be at 5 or 6 by the end of the phase 2. We are looking for any transition partners to help us get this as far down the tier L path as possible. One of the key features that the system handles is ambiguity. Obviously, their English language is extremely ambiguous. For example, you can have things such as children make delicious snacks. Well, are they cooking good snacks, or are they actually being eaten, which would be kind of sick? I saw the Rockies flying to San Francisco. Are you talking about the mountains or a baseball team? Government head seeks arms, obviously one here. And then patient at death's door, doctor pulls him through. Does he save him, or does he push him through the door? Those are some simple examples of ambiguous statements, but in military operations, there are always ambiguous information that's included in any communication. Someone could say that they see something 100 meters west of my position. Well, if you're not 100% clear about where your position is, that'll have to be inferred from previous conversations or additional information. Similarly, advise when ready for routing. What routing are you waiting for? What routing are you going to send them? The Smart Translation System is being trained to make the leaps of knowledge that are required to determine the correct interpretation of these types of sentences, as well as more complex ones as well. The idea here is that the users aren't going to be perfectly clear in their communication. This is something that humans are very familiar with, and they are able to quickly make these kinds of leaps of knowledge. However, autonomous systems do not innately have this capability, and so the Smart Translation System is being built specifically to handle this issue and to resolve it. A second feature of the Smart Translation System is the ability to handle implications. An implication is something where you say one thing that implies additional information that a human is very quickly able to understand. Autonomous systems, not so much so. So if you say Joe ate a piece of cake, it implies very specifically that there is a cake that he ate. It also implies that Joe did not eat the entire cake, because if he had, you wouldn't have said a piece of cake. So there's a level of specificity in the way that people talk that says if you use these specific words, then you assume that you would have used more specific words or less specific words if some other information would have been necessary. Also, it does not imply that Joe also ate some ice cream. He may have, he may not have. The statement that Joe ate a piece of cake does not in any way infer or imply that Joe ate ice cream. Similarly, her hair is the color of grass. Okay, so it implies that she has hair. It probably means that it's green, and it also most certainly means that it was dyed. However, there is a level to different implications. The fact that she has hair is a very heavy implication, whereas the fact that it was dyed and not turned green in some other way is a much less strong implication. In military terms, an example is take the hill at all costs. Okay, but if we all die, but we're at the top of the hill, were we really successful? Typically, one would assume that the commander does not mean take the hill at all costs includes the death of your entire team. It may mean the loss of certain equipment or having to deal with enemy forces. But it certainly does not imply that everyone should probably die on top of the hill. Similarly, protect the bunker. There's some implications here that you need to be able to pull out. Who and what are we protecting it against? Which bunker and where is it? What does it mean to protect it? Are we protecting the structure of the bunker or the people and equipment inside the bunker? The Smart Translation System is built to be able to infer these types of information and provide the additional information that wasn't necessarily stated by the human to the autonomous system. An example of the overall information extraction capability for the Smart Translation System is given here. For example, land on the beach and covertly make your way to the tree line, maneuver to Area A, scout enemy position, breach Building B and neutralize the HVD, exfil back to the landing, craft and return, and weapons on hold unless in imminent danger. So that's a lot of information that a Marine or sailor or soldier would understand very quickly. However, an autonomous system would have no idea how to interpret this without the smart's capability. So our focus is to be able to extract each of those 10 different pieces of information, as well as additional information as necessary. So land on the beach before going to the tree line, on down the line, go down to number 8. If at any time you believe you, your squad member, or any higher unit is endangered, you are permitted to preemptively fire. Whereas it may interpret it differently if it didn't have the Smart Translation System. It very specifically tells you that the HVT is in Building B. It also pulls out acronyms so that it'll understand that HVT is a high-value target. And then if any given suppositions are not met, adapt as necessary to preserve unit squad's security and mission effectiveness. It's probably the most important thing to tell an autonomous system that allows it to understand that, yes, these are your guidelines, but if you're intelligent enough of a system, you're allowed to modify slightly as necessary. However, that does require that the autonomous system is advanced enough to be able to adapt appropriately. In terms of our transition status, we're currently building the system. We have a complete end-to-end system that has been demonstrated across a number of different exercises and experiments, but we are looking for a phase 2, phase 3 transition partner. If you are interested in looking to talk to us, please reach out. For DoD transition partners, the system. It will be provided royalty free, and we can update the system as necessary to work within your environment, particularly if it's scheduled before the end of the phase 2. We can utilize some of the funding that we do have to help transition it and make it fit within your program of record. As an overview of potential commercial use cases, these are just a couple. There are obviously a number more that we've thought of, or quite a few probably, that we haven't thought of that you might have thought of. If you have, please let us know. But some of the ones that we've come up with are automated writing assistants. So if we are capable of understanding where issues are in the completeness or implications or ambiguousness of knowledge, we can provide feedback to the writer as to where they can better be more clear within their language. In addition, we have a number of sports and esports capabilities as a corporation. Being able to tie this in as a training assistant and being able to take all the analytics that we have and converting the analytical results into a natural language that a user will understand is a specific use case that we're looking at. And then similarly, we could do the same thing within other markets, including transportation, product design, surgical tools, and many others. We are looking to license this to other developers or other companies as necessary to fit specific commercial markets. If you're interested, please definitely don't hesitate to reach out to us. I want to thank you for taking the time to listen to our presentation. Again, my name is Jonathan Day from Machina Cognita Technologies. If you have any questions at all for us, any feedback, or you want to see a demo of our capabilities, please don't hesitate to reach out. My phone number and email address are on the slide, as well as our location and our website. I look forward to hearing from you. And again, thank you very much for your time.